Section 3 is D1.2 and D1. 3, the two subdomains that separate candidates who just know how to click around Azure ML Studio from candidates who know how to build repeatable, governed, automated ML infrastructure. Assets, registries, bicep, GitHub Actions, and security. Let's go. In Azure ML, an environment is not just a Python virtual environment. It's a version specification of the entire execution context for a training job. The base Docker image, the Python packages, the system libraries, and any custom dependencies. The version tracking makes jobs reproducible. You can rerun a training job from 6 months ago and get the exact same environment it ran in originally. Start with curated environments before building custom ones. Microsoft maintains a catalog of curated environments for the most common ML frameworks. sklearn 1.5 for scikit-learn work, PyTorch 2.2 for PyTorch, TensorFlow 2.15, and so on. These are tested, regularly updated with security patches, and cached in AML's container registry, which means they start faster than custom environments. Use curated environments whenever they meet your requirements. The only reason to build custom is when you need packages or system libraries that aren't in the curated options. When you do need a custom environment, you define it with a YAML file that specifies either a base Docker image plus a conda specification or a Docker file for full control. The YAML gets registered with azml environment create -file nv YAML. The first creation is version 1. Each subsequent create auto-increments the version. Once registered, jobs reference the environment by name and version. Environment: Azure ML, My Training, and V. 3. The exam scenario that tests environments most frequently. A training job runs correctly in a data scientist compute instance, but fails on the compute cluster with a missing package error. Root cause: the data scientist instance has packages installed manually that aren't in the registered environment. Fix: add the missing package to the environment YAML, register a new version, and pin the job to the new version. For environments that multiple teams need, for example, a company standard PyTorch environment with approved libraries, register the environment to a register, not just a workspace. That way, every workspace can reference it without each team building their own copy. A component in Azure ML is a reusable, versioned unit of ML work. Think of it like a typed function that you can compose into pipelines. A data prep component takes raw data as input and outputs train/test splits. A training component takes training data and outputs a trained model. An evaluation component takes a model and test data and outputs metrics. You build these components once, register them, and then compose pipelines by connecting them. The output of one component becomes the input of the next. The component YAML has a specific structure that appears on the exam. It requires a name, a version, a list of typed inputs with their types, URI _ folder, number, integer, string, a list of typed outputs, the environment the component runs in, and the command that executes the component. The command uses template syntax to reference inputs and outputs, and outputs.train_data and outputs.model_output. That template syntax is how AML wires data between pipeline steps. Why are components better than just writing a pipeline script? 3 reasons. First, reusability. The same data prep component works across 20 different pipelines without copy-pasting code. Second, versioning. You can update the training component to version 2 and explicitly choose which pipelines upgrade versus stay on version 1. Third, testability. You can test a component in isolation before wiring it into a pipeline. For the exam, components connect to 2 domains. In D1.2, they're workspace assets that need to be managed, versioned, and shared via registries. In D2.1, they're the building blocks of Azure ML training pipelines, the next major topic in Module 2. Get the component YAML structure into your mental model now so that when we build pipelines in Module 2, the pieces click into place immediately.